Did you know that space has its own peculiar smell? Astronauts report that when they come back inside after a spacewalk, their suits carry a strange scent like seared steak, hot metal, and even gunpowder. It's one of those bizarre little secrets of the cosmos that reminds us just how alien space really is. And that's just the beginning. The universe is packed with mysteries so strange, so unexpected, they almost feel like science fiction. But here's the thing, they're absolutely real. Think about it. We've sent robots to Mars, discovered planets made of diamond, and even found a black hole that sings. Every time we peel back another layer of the cosmos, it throws something new and astonishing at us. That's exactly what makes space exploration so thrilling. It's not just about facts and figures, it's about the sheer wonder of uncovering truths that challenge everything we thought we knew. And today, we're diving deep into 30 of the weirdest, most mind-bending discoveries humanity has made beyond our planet. Some of these facts will make you laugh, some might send a shiver down your spine, and others, well, they'll make you stop and stare at the night sky a little differently. Because space isn't just some distant, silent void, it's alive with weirdness, bursting with phenomena so incredible they defy imagination. So buckle up. We're about to take a journey through the odd, the wonderful, and the downright unbelievable. And trust me, by the time we're done, you'll never look at the stars the same way again. Here's something that might make you wish for a trip to space, at least for a little while. Astronauts actually grow taller when they leave Earth, not by magic but by science. In microgravity, the spine isn't constantly compressed by gravity like it is on Earth. Without that pressure, the fluid-filled discs between vertebrae expand, stretching the spine. The result, astronauts can gain up to 2 inches in height while floating around the International Space Station. Imagine waking up one morning and suddenly needing longer pants because space literally made you taller. But there's a catch: this cosmic growth spurt doesn't last. Once back on Earth, gravity takes over again, squishing those discs back down to their usual size. And that's where things get uncomfortable. Many astronauts report intense back pain and even issues with spinal fluid pressure as their bodies readjust. Some compare the sensation to the weight of an entire person suddenly pressing down on their spine after months of floating freely. Take astronaut Scott Kelly, who spent nearly a full year in space. He famously grew 2 inches taller during his mission, only to shrink right back to normal within 2 days of returning home. That kind of rapid change isn't just weird, it's a reminder of how deeply our bodies depend on Earth's gravity. Every cell, every muscle, even our bones evolved under its constant pull. So while growing taller in space sounds like a fun perk, our bodies weren't really built for it long term. And here's another twist: this height boost can actually cause problems in space too. Astronauts have to account for their changing dimensions when designing spacesuits and spacecraft. What if you grew just enough to bump your head on equipment that fit you perfectly at launch? It's one of those bizarre little challenges that makes space travel so much more complicated and fascinating than it seems. Because even the simplest things, like standing up straight, work differently when you're off the planet. The moon might seem like a silent, lifeless world, but beneath its dusty surface, it's actually shaking. That's right, moonquakes are real, and they're nothing like the earthquakes we experience here on Earth. Back in the late 1960s and early 70s, Apollo astronauts left seismometers on the lunar surface, and what they recorded was astonishing. The moon isn't just occasionally trembling. It's a geologically active place with quakes that can last for hours, far longer than the brief, violent shakes we're used to on our planet. So what causes these eerie lunar tremors? Unlike Earth, where quakes are mostly driven by tectonic plates shifting and grinding, moonquakes come from entirely different forces. Some are triggered by tidal flexing, the gravitational tug of war between the moon and Earth, which subtly stretches and compresses the lunar crust. Others happen because of extreme temperature swings. The moon's surface can swing from scorching 260 degrees Fahrenheit in sunlight to a bone-chilling 280 below zero in the shadow. Over time, this brutal heating and cooling makes the rock expand and contract, creating cracks and seismic shudders. Then there are the deep moonquakes originating hundreds of miles below the surface, likely tied to the moon's slow cooling over billions of years. These can reach up to 5.5 on the Richter scale, strong enough to rattle equipment if astronauts were living there long term. But here's the strangest part. While Earth's quakes usually last seconds or minutes, moonquakes can go on for 10 minutes or more. Imagine standing on the moon and feeling the ground vibrate beneath you for that long, no quick jolt, just a slow, rolling shudder echoing through the rock. This discovery completely changed how we see the moon. It's not a dead relic of the solar system, it's still alive, still shifting, still reacting to the forces around it. And that has huge implications for future lunar bases. If we're going to build habitats there, we'll need to account for these quakes, making sure structures can withstand hours of shaking without crumbling. The Apollo seismometers were just the beginning. Today's scientists are eager to send new instruments to the moon, peeling back even more of its seismic secrets. Because every moonquake isn't just a tremor. It's a message from the moon itself, whispering clues about its hidden past and restless present. Venus is the solar system's ultimate rebel, the only planet that spins backward. While every other planet in our neighborhood rotates counterclockwise when viewed from above the North Pole, Venus defiantly spins clockwise. This bizarre retrograde rotation isn't just a quirky detail. It's one of the biggest unsolved mysteries in planetary science. So why does Venus buck the trend? Scientists have a few compelling theories. One suggests that early in the solar system's history, a colossal collision, perhaps with a protoplanet the size of Mars, could have knocked Venus spinning in the opposite direction. Imagine two celestial billiard balls smashing together so violently that they flipped an entire world's rotation. Another possibility involves gravitational chaos. Venus orbits close to the Sun, and over billions of years, the intense tidal forces from our star combined with the tug of its thick, soupy atmosphere might have gradually slowed its original spin to a standstill before reversing it entirely. It's like a cosmic game of tug-of-war where the Sun's gravity won, but in the most unexpected way. Here's where it gets even weirder. A single day on Venus lasts longer than its entire year. That's right, while it takes Venus just 225 Earth days to complete one orbit around the Sun, it spins so sluggishly that one full rotation takes 243 Earth days. If you lived on Venus, you'd celebrate your birthday before you finished a single sunrise to sunrise cycle. This extreme mismatch between day and year creates one of the most alien day-night rhythms imaginable. Picture a world where the sun rises in the west, sets in the east, and takes months to crawl across the sky. Add in Venus's thick, toxic clouds that trap heat like a runaway greenhouse, and you've got a planet that feels more like a slow-motion dystopia than a neighbor. Yet this backward spin might hold clues to Venus's turbulent past. Some researchers think it hints at ancient cataclysms, either a dramatic collision or a gravitational wrestling match that reshaped its fate. Others speculate that early Venus might have had moons or even a different axial tilt before something knocked it off course. Every new mission to Venus, like NASA's upcoming Veritas orbiter, brings us closer to unraveling this puzzle. One thing's certain, Venus doesn't play by the rules. While other planets march in orderly formation, it dances to its own rhythm, a reminder that even in the seemingly predictable cosmos, there's always room for the extraordinary. And for scientists, that's what makes this backward spinning world one of the most fascinating places in the solar system. If you think space is all about rocks and radiation, buckle up, because there's a massive cloud of alcohol floating near the center of our galaxy. Meet Sagittarius B2, a colossal molecular cloud packed with billions of liters of ethyl alcohol. That's right, enough booze to fill an interstellar bar 1,000 times over. But before you start picturing alien happy hours, there's a catch. This cosmic cocktail is laced with methanol, a toxic cousin of drinking alcohol. One sip and you'd be in serious trouble. So how does a cloud like this even form? It all comes down to chemistry in the void. In the frigid depths of space, simple atoms like carbon, hydrogen, and oxygen bump into each other, sticking together to form complex molecules. Over millions of years, these molecules accumulate into vast, swirling clouds, some spanning light years across. Sagittarius B2 is one of these cosmic breweries where the ingredients for everything from stars to life itself are stirred together. But here's the wild part. Clouds like this aren't just floating bars, they're stellar nurseries. The same alcohol molecules we're talking about are also building blocks for far grander things. When gravity pulls these clouds together, they collapse into dense knots that ignite as brand new stars. And around those stars, leftover molecules clump into planets, comets, and maybe even the precursors to life. In a way, that giant alcohol cloud isn't just a curiosity, it's a snapshot of the raw materials that built our solar system. What's even more mind-blowing is the scale. Sagittarius B2 contains enough ethyl alcohol to fill thousands of Olympic-sized swimming pools. And it's not alone. Similar clouds with other organic molecules like sugar and vinegar have been spotted throughout the galaxy. That means the universe isn't just making stars and planets, it's brewing up the chemical foundations for complexity everywhere we look. So while we can't actually drink from this cosmic keg, its existence hints at something profound. The ingredients for life aren't rare or special. They're scattered across the galaxy, waiting for the right conditions to mix, collapse, and maybe, just maybe, spark something new. And that's the real buzzkill about Sagittarius B2. Not that its alcohol is poison, but that it reminds us just how ordinary, and yet how extraordinary, the building blocks of existence really are. The sun may look like a bright, steady disk in our sky, but beneath its glowing surface rages an unimaginable powerhouse, one so vast it could swallow our entire planet without a second thought. Picture this: the sun's core alone, just the very center of it, could hold 1.3 million Earths crammed inside. That's not the whole sun, just its heart, a seething nuclear furnace where temperatures soar to 27 million degrees Fahrenheit. This is where the magic, or rather the physics, happens. Every second, the sun's core smashes together hydrogen atoms in a process called nuclear fusion, turning them into helium and releasing enough energy to power our solar system. But here's the twist: that energy doesn't zip straight to the surface like a beam of light. Instead, it gets trapped in a chaotic dance, bouncing between particles in the sun's dense plasma. A single photon of light born in the core takes a staggering 40,000 years just to fight its way to the surface. Imagine setting off on a journey where every step forward is met with a shove sideways. That's the grueling path energy takes to finally break free and shine into space. Now here's a number that puts the sun's sheer power into perspective. It loses 4 million tons of mass every single second, converted directly into energy through fusion. To put that in context, that's the weight of a small mountain vanishing, not burning, not exploding, just transforming into pure light and heat. And yet, even at that rate, the sun has enough fuel to keep burning for another 5 billion years. It's like holding a bonfire the size of a planet, tossing entire forests into the flames every minute, and still having enough wood to outlast human civilization 1,000 times over. But scale isn't the only mind-bending thing about the sun's core. The conditions there are so extreme they defy earthly logic. The pressure is 250 billion times what we feel at sea level, enough to crush atoms into a superheated plasma soup. Even the sound is unimaginable. If you could stand in the core, which of course you can't, the nuclear reactions would create a constant, deafening roar louder than a million hurricanes. It's a place where the rules of physics as we know them are pushed to their absolute limits, and yet all that fury is hidden beneath a serene, golden surface. The sun's calm exterior belies the storm within, a reminder that sometimes the most ordinary-looking things in the universe are anything but. Every sunset, every sunbeam, every warm summer day traces back to that incomprehensible inferno where matter itself is rewritten to keep our world alive. So next time you feel the sun on your skin, remember, you're feeling the echo of a fire that started 40,000 years ago in a place so vast it could fit 1,000,000 Earths and still have room to spare. Neptune might be the most distant planet in our solar system, but it's far from a cold, dormant world. In fact, this ice giant is practically burning up with energy, literally. Despite being nearly 3 billion miles from the sun, Neptune radiates 2.6 times more heat than it actually receives from our star. That's like sitting in a freezing room and somehow generating your own warmth without a heater. Even more baffling, its near twin, Uranus, barely emits any excess heat at all. So why is Neptune practically glowing with energy while Uranus languishes in the cold? One leading theory points to the leftovers of Neptune's violent birth. When planets form, the collisions and gravitational chaos generate immense heat, which can take billions of years to dissipate. Neptune might still be cooling down from that primordial chaos, slowly releasing trapped energy like a cosmic furnace. But here's the twist: Uranus went through the same process, so why isn't it doing the same? Some scientists think Neptune's internal dynamics are just more efficient at channeling that heat upward, while Uranus's sluggish atmosphere might trap it deeper inside. Then there's the diamond rain hypothesis. Yes, you heard that right. Deep inside Neptune's atmosphere, where pressures are crushing and temperatures soar, methane molecules break apart. The carbon atoms, freed from their bonds, could theoretically compress into diamond crystals, which then sink like glittering hailstones through layers of dense, slushy material. As these diamonds plummet, friction from their movement might generate additional heat, like rubbing your hands together on a frosty day. It's a wild idea, but lab experiments mimicking Neptune's conditions have shown that diamond rain could indeed be real. The contrast between Neptune and Uranus is one of the solar system's great puzzles. Both are ice giants, both formed from similar materials, yet their energy budgets couldn't be more different. Uranus, tilted sideways and eerily calm, reflects almost all the sunlight it receives, like a mirror floating in space. Neptune, on the other hand, churns with violent storms and supersonic winds, its excess heat likely fueling those chaotic weather patterns. So what's the takeaway? Neptune's mysterious warmth reminds us that even the farthest reaches of our solar system are anything but dead or quiet. There's a turbulent, dynamic world out there, defying expectations and challenging our understanding of how planets evolve. And with every new discovery, we're left with more questions than answers, which is exactly what makes space exploration so thrilling. Space isn't just quiet, it's utterly, absolutely silent. That iconic line from Alien, "In space, no one can hear you scream," it isn't just Hollywood flair, it's physics. Sound needs something to travel through, whether it's air, water, or even solid ground. But in the vacuum of space, where molecules are spread thinner than a whisper, there's nothing to vibrate, nothing to carry those waves. So if you were floating alone out there and shouted at the top of your lungs, your voice would vanish into the void without a single echo. That silence became hauntingly real for the Apollo astronauts. When they orbited the far side of the moon, completely cut off from Earth's radio signals, all communication with mission control went dead. No static, no background noise, just eerie, total quiet. The only sounds they ever heard in space came through their headsets, crackling transmissions from home. Otherwise, it was a soundproof prison where even the roar of a nearby explosion wouldn't reach their ears. Of course, science fiction loves to ignore this inconvenient truth. Star Wars wouldn't be the same without the scream of TA fighters or the thunderous boom of distant explosions. but those dramatic sound effects, pure artistic license. In reality, a supernova could rip through a galaxy in total silence, and two spaceships colliding would happen in chilling quiet. Even the sun, a raging nuclear furnace, doesn't make a peep in the vacuum. Its fury is utterly mute. This absolute stillness makes space exploration uniquely isolating. On Earth, sound connects us to our surroundings, the rustle of leaves, the hum of a city. But in space, that sensory thread is severed. Every astronaut who stepped outside the International Space Station describes the same surreal experience, floating in perfect silence, watching the machinery of their suit move without noise, as if trapped inside a cosmic silent film. Yet there's a strange beauty to it. That silence isn't just absence, it's a reminder of how alien the cosmos really is. Our brains aren't wired to process a world without sound, which makes space's hush one of its most unsettling, awe-inspiring truths. So next time you hear a spaceship roar in a movie, smile, and remember the real universe operates on mute. Mercury might be the closest planet to the Sun, but hidden in its darkest corners lies something astonishing: ice. That's right, the scorching world where daytime temperatures soar to a blistering 800 degrees Fahrenheit has pockets of frozen water tucked away in its polar craters. NASA Messenger probe confirmed it. Despite being practically next door to a cosmic furnace, Mercury holds onto ice like a planetary magician pulling off the ultimate sleight of hand. So how does ice survive on a planet where sunlight is 11 times stronger than Earth's? The secret lies in Mercury's bizarre geography. Some craters near the poles are so deep and steep-walled that sunlight never touches their floors. These permanently shadowed regions plunge to temperatures as low as 290 degrees below zero, cold enough to preserve ice for billions of years. It's like finding a freezer tucked inside an active volcano. But where did this ice come from? The leading theory points to cosmic delivery trucks, comets, and water-rich asteroids that smashed into Mercury over eons. Each impact scattered water molecules across the surface, and while most evaporated instantly under the sun's glare, a fraction bounced randomly until some landed in those shadowy polar traps. There they stayed, accumulating over millennia into patches of ice we can now detect. The irony is almost poetic. The planet named after the fleet-footed Roman god, the one that races around the sun faster than any other, has been quietly hoarding frozen water all this time. Mercury's dayside could melt lead, yet its poles harbor relics of ancient cosmic collisions, perfectly preserved in eternal darkness. This discovery rewrote the rulebook for planetary science. If Mercury, of all places, can hold onto ice, then water might be far more common in the solar system than we ever imagined. It's a reminder that even the harshest environments can hide delicate surprises, if only we know where to look. And for future explorers, those icy craters could be more than just scientific curiosities. They might be the key to survival on a world where every other drop of water should have boiled away eons ago. Pluto may be small, but it moves at its own leisurely pace. A single day on this distant world lasts 6.4 Earth days. That means if you stood on its icy surface, you'd watch the sun crawl across the sky for over a week before it finally set. This sluggish spin isn't just a quirk, it's tied to Pluto's cosmic dance with its largest moon, Charon. The two are so close in size and so tightly bound by gravity that they've become locked in a gravitational embrace, forever facing each other like partners in a slow-motion waltz. In fact, their relationship is so unique that some scientists argue they shouldn't even be called a planet and moon. They're more like a double-planet system, two worlds orbiting a shared point in space. Charon's influence doesn't stop there. Because it's so massive relative to Pluto, the moon's gravity has literally slowed its partner's rotation over billions of years, stretching Pluto's day into that marathon 6.4-day cycle. If you were standing on Pluto's surface, Charon wouldn't rise or set like our moon does. It would hang motionless in the sky, a silent sentinel fixed in place. Meanwhile, Pluto's other, smaller moons, Styx, Nix, Kerberos, and Hydra, zip around chaotically, their orbits tugged and twisted by the gravitational tug of war between the two larger bodies. When NASA, a New Horizons spacecraft, flew past Pluto in 2015, it captured stunning images of this strange world, including its iconic heart-shaped glacier, Tombaugh Regio. This bright, frozen plain, roughly the size of Texas, is made mostly of nitrogen ice, shifting and cracking over time as Pluto's slow rotation exposes it to the faint warmth of the distant sun. The spacecraft also revealed towering ice mountains and hazy blue skies, proving that even at the edge of the solar system, Pluto is geologically alive. Now compare Pluto's laid-back spin to Haumea, another dwarf planet out beyond Neptune. Haumea is in such a hurry that it completes a full rotation every 4 hours, making it one of the fastest spinning objects in the solar system. This bizarre speed has stretched Haumea into a football-like shape, as if the planet itself is barely holding together under the centrifugal force. Scientists think this breakneck spin might be the result of a colossal collision billions of years ago, a cosmic crash that sent Haumea tumbling like a kicked ball. So why does this matter? Because these wildly different rotations tell us that dwarf planets aren't just frozen leftovers, they're dynamic worlds with unique histories. Pluto's slow, synchronized dance with Charon suggests a calm, orderly past, while Haumea's frantic whirl hints at ancient violence. Each rotation rate is a clue, a piece of the puzzle in understanding how these distant worlds formed and evolved. And as we discover more dwarf planets, each with its own spin, we're reminded that the outer solar system is anything but predictable. It's a place where worlds move to their own rhythms, some slow and steady, others racing against time. Jupiter's Great Red Spot isn't just a storm, it's a solar system icon, a swirling tempest so vast it could once swallow 4 Earths side by side, but this ancient beast is shrinking. For centuries, astronomers have watched its crimson whirl grow smaller, fading like a cosmic tattoo. Today, the storm spans barely 1 Earth, still monstrous by our standards, but a shadow of its former self. So is the Great Red Spot dying, or is it just transforming into something new? The storm's history reads like a celestial mystery. First spotted in the 1600s, it's raged for at least 400 years, long enough to witness the entire span of human space exploration. Early telescopic observations showed a churning oval 3 times wider than our planet, its winds screaming at 430 miles per hour. But by the time NASA Voyager probes flew past in the late 1970s, it had already slimmed down. Decades later, Hubble images revealed a startling trend. The spot wasn't just shrinking, it was changing shape, stretching taller even as it narrowed, like taffy pulled from both ends. Enter Juno, NASA, a fearless Jupiter orbiter. Since 2016, this spacecraft has dived perilously close to the storm, peeling back its secrets. Juno's data shows the spot isn't just wide, it's deep, plunging 200 miles into Jupiter's atmosphere, with roots possibly anchored in the planet's hidden layers. That depth might explain its longevity. Unlike Earth's hurricanes, which fizzle without warm ocean water, the Great Red Spot feeds off Jupiter's internal heat, drawing energy from below like a vampire tapping into the planet's lifeblood. Yet even with that advantage, the storm is undeniably changing. Winds at its edges are speeding up while the core seems to writhe with new turbulence. Some scientists think it's shedding massive fragments, cyclones the size of continents that spin off like embers from a bonfire. Others argue it's simply evolving, condensing into a denser, fiercer version of itself. There's even a haunting possibility. The Great Red Spot might vanish entirely within our lifetimes, leaving Jupiter's face unrecognizable to future generations. What happens if it disappears? Jupiter's atmosphere is a battlefield of storms, and the spot has long been its king. Without it, smaller tempests could clash unchecked, rearranging the planet's striped cloud bands. Or perhaps something new will rise, a storm even more terrifying. proof that Jupiter's fury never truly fades, only reshapes. The Great Red Spot's fate isn't just about one storm, it's a window into the heart of a giant, reminding us that even the mightiest things in the cosmos are never permanent. Just fleeting wonders spinning against the dark, Saturn's rings are the solar system's ultimate illusion. They look eternal, shimmering like a cosmic halo, but they're actually younger than some dinosaurs. That's right, when Tyrannosaurus Rex roamed Earth, Saturn stood bare, its iconic rings nothing more than stardust waiting to be born. Thanks to NASA's Cassini mission, we now know these dazzling bands are a fleeting spectacle, likely just 10 to 100 million years old. In cosmic terms, that's a blink of an eye. So why didn't Saturn always have rings? The answer lies in their delicate balance. Unlike the static, unchanging disks they appear to be, the rings are constantly under siege. Micrometeoroids bombard them, sunlight erodes their icy particles, and gravity tugs them apart. Left unchecked, these forces would have ground the rings to dust eons ago. But here's the twist, they're also being rebuilt. Cassini spotted plumes of fresh ice spraying from Saturn's moons, especially tiny Enceladus, whose geysers feed new material into the rings like a cosmic conveyor belt. Collisions between moons or icy comets likely kick up even more debris, creating a cycle of destruction and renewal that keeps the rings shining for now. But nothing lasts forever. Saturn's gravity is slowly winning the battle, dragging ring particles inward like a celestial hourglass running low. Cassini's final, daring orbits revealed the rings are losing enough water every half hour to fill an Olympic-sized pool. At that rate, scientists estimate they'll fade completely in another 300 million years, a whisper in the universe's timeline. What's truly mind-bending is the scale of this ephemeral beauty. The rings stretch 280,000 miles across, yet they're barely as thick as a skyscraper is tall. Imagine something so vast, so breathtaking, vanishing before your eyes, not in millennia, but in cosmic real time. It's a humbling reminder, even the grandest features of our solar system are temporary, flickering like candlelight against the dark. And we're the lucky generation that gets to see them in their prime. The next time you gaze at Saturn through a telescope, remember, you're witnessing a cosmic accident, a fleeting masterpiece that won't last. Those rings weren't here when the dinosaurs ruled, and they'll be gone long before Earth's next great chapter unfolds. In a universe where change is the only constant, Saturn's dazzling jewelry is proof nothing, not even the heavens, stays the same forever. Mars flips the script on one of Earth's most familiar sights. Sunset isn't a fiery blaze on the red planet, but an eerie blue glow. While our skies here turn gold and crimson as the sun dips below the horizon, Martian sunsets paint the heavens in cool shades of sapphire and periwinkle. NASA Perseverance rover captured this otherworldly spectacle in stunning footage, showing the sun shrinking into a pale, azure disk before vanishing behind the dust-choked sky. So why the cosmic color swap? It all comes down to dust, the wrong kind for red sunsets. Earth's atmosphere scatters shorter blue wavelengths of light, letting longer red and orange tones dominate at sunrise and sunset. But Mars's fine, iron-rich dust hangs thick in the thin air, scattering red light sideways and letting blue light slice straight through to your eyes. The effect is strongest when the sun is low, its light traveling through more of the dusty atmosphere. It's like the difference between shining a flashlight through clean water, which looks blue, versus murky water tinged with clay, which glows reddish. Imagine standing on Mars as the sun sinks below the rim of Jezero crater. The rusty landscape darkens, but the sky above you takes on a twilight hue unlike anything on Earth. The sun itself appears shrunken, just 2/3 the size we're used to, its light diffused by the endless dust. There's no warm afterglow, just a quiet, blue-tinged dimming that makes the whole scene feel like a dream. For future colonists, this daily phenomenon won't just be a scientific curiosity. It'll be their evening masterpiece, a reminder that even ordinary moments become extraordinary on another world. The poetry of Martian sunsets isn't lost on scientists. When Perseverance's cameras first beamed back footage of the event, even seasoned researchers paused in awe. The rover's Mastcam-Z instrument, designed to analyze rocks and dust, accidentally became an interplanetary cinematographer, documenting a phenomenon no human eyes have witnessed directly. Those images aren't just pretty, they're clues. By studying how light dances through Mars's atmosphere, we learn about the size and composition of its dust particles, which drive everything from weather patterns to the planet's notorious global dust storms. But perhaps the most haunting thought is this: Mars wasn't always this way. Billions of years ago, when its skies were thicker and its rivers flowed, sunsets might have looked more like Earth's golden light reflecting off watery surfaces. Now, the blue hour serves as a silent testament to how drastically the planet has changed. Every sunset there is a double vision, what we see today and what might have been. And for those who eventually call Mars home, that daily azure farewell will be more than just a pretty sight. It'll be the signature of their adopted world, written in light and dust. Imagine a world where the ground beneath your feet isn't rock or soil, it's diamond, not scattered gemstones, but an entire planet where carbon has crystallized into a glittering planetary-scale jewel. Meet 55 Cancri E, a so-called super-Earth twice our planet's size, orbiting so close to its star that a single year lasts just 18 hours. But its blistering speed isn't the strangest thing about it. This world's interior could be up to a third pure diamond, forged in the crushing pressures of its carbon-rich core. Discovered in 2004, 55 Cancri E quickly stood out as an oddball even among exotic exoplanets. Its parent star, 55 Cancri, is unusually rich in carbon, and when planets form from such a carbon-heavy protoplanetary disk, their chemistry gets warped in bizarre ways. Think of it like baking a cake with 10 times the usual sugar. The end result won't be anything like a normal dessert. In this case, the ingredients produced a planet where oxygen is scarce but carbon is everywhere. Under extreme heat and pressure, that carbon could have compressed into a crystalline lattice, Earth's diamonds, but on a planetary scale. Now, before you start plotting an interstellar heist, consider the catch. 55 Cancri E is anything but hospitable. Its surface temperature hovers around 2000 degrees Celsius, hot enough to vaporize titanium, while tidal forces from its star have likely locked one side in perpetual scorching daylight and the other in endless dim twilight. Current models suggest its surface might be a global lava ocean, with vaporized rock forming a thin, poisonous atmosphere. Any diamond crust wouldn't be a solid sheet, but more like a colossal, cracked flow adrift on a molten sea, constantly churning and reforming. What's truly mind-bending is how this world forces us to rethink planetary diversity. We're used to rocky planets like Earth or gas giants like Jupiter, but 55 Cancri E defies those categories entirely. It's a carbon planet, a hypothetical class long theorized but difficult to confirm. While its diamond interior remains unproven, alternate theories suggest graphite or even exotic carbon compounds. The very possibility reshapes our understanding of what planets can be. If diamonds can form on this scale, what other impossible-seeming worlds are waiting to be found? And here's the cosmic punchline: 55 Cancri E might not be alone. Other carbon-rich stars could host similar gem-studded worlds, each more bizarre than the last. Some might have layers of diamond miles thick, others could harbor oceans of liquid carbon or rainstorms of tar. It's a reminder that the universe doesn't just replicate Earth-like conditions. It invents, experiments, and occasionally crafts a planet so ludicrously opulent it puts galactic royalty to shame. So while we'll never mine 55 Cancri E's diamond heart, its existence sparks something far more valuable: wonder at the sheer audacity of the cosmos. The Hubble Space Telescope, launched with dreams of delivering crystal-clear views of the cosmos, But when its first images reached Earth in 1990, scientists gasped. Instead of razor-sharp stars, the pictures were blurry, like a camera lens smeared with grease. The culprit, a flaw in Hubble's primary mirror, polished with a staggering error, just 2 microns too flat at the edges. That's 1/50th the width of a human hair, a mistake tinier than a grain of pollen, yet enough to cripple a $2.5 billion telescope. What followed was one of NASA's most humbling moments. The mirror's imperfection scattered light, rendering Hubble nearly blind to fine details. Some called it a national embarrassment, others feared the mission was doomed. But here's where the story twists. Hubble's greatest failure set the stage for its most spectacular redemption. Engineers devised a fix as ingenious as it was daring, a set of corrective lenses like eyeglasses for a telescope to counteract the flaw. Installing them meant sending astronauts on a high-stakes repair mission, something never before attempted in space. In December 1993, the space shuttle Endeavour rendezvoused with Hubble, and over 5 nerve-wracking days, astronauts performed what amounted to orbital eye surgery. They swapped cameras, replaced solar panels, and most crucially installed the corrective optics package CoStar. The tension was unbearable had it worked. When the first post-repair image flashed onto screens, a star cluster in sharp, luminous detail, the room erupted. Hubble wasn't just fixed, it was reborn. The comeback transformed astronomy. Freed from its myopia, Hubble began capturing images that rewrote textbooks, the pillars of creation, galactic collisions, the deepest views of the universe ever seen. Its clarity let scientists measure the universe's expansion rate, discover moons around Pluto, and peer at galaxies born just after the Big Bang. That 2-micron error, once a symbol of failure, became a footnote in a legacy of triumph. Hubble's story isn't just about technology, it's a testament to human grit. The telescope could have been written off as a lost cause. Instead, engineers turned a disaster into a defining moment for space exploration. Every breathtaking Hubble image since every nebula, every galaxy carries the echo of that rescue, proving that even the mightiest stumbles can lead to the greatest leaps. And that's the real lesson. In science, as in space, perfection isn't the starting point, it's the destination. Drinking recycled urine might sound like something out of a dystopian sci-fi movie, but on the International Space Station, it's just another day at the office. In fact, the ISS's water recovery system is so advanced that every drop of liquid, from sweat to shower runoff to urine, gets purified and turned back into clean, drinkable water. And here's the kicker, it's not just a backup plan. This system recycles about 93% of all water on board, making it one of the most efficient closed-loop systems ever created. Let's break down the magic behind this process. Urine first goes through a distillation system that heats it to create steam, leaving behind the gross stuff, salts, toxins, and other waste. That steam is then cooled back into water, but it's not quite ready yet. Next, it's filtered through a series of chemical reactors and catalysts that break down any remaining impurities. Finally, the water passes through advanced filters that catch even the tiniest contaminants, leaving it cleaner than most tap water on Earth. By the time it reaches an astronaut's cup, it's gone through a transformation so thorough you'd never guess its origins. Now, if you're cringing at the thought, you're not alone. Even astronauts admit the idea takes some getting used to. NASA Don Pettit once joked that the best part about drinking recycled urine is the psychological barrier you have to overcome. But the science doesn't lie. Independent tests have shown the water produced by the ISS system meets, and often exceeds, the purity standards of municipal water supplies back home. It's so clean that crew members sometimes add a hint of flavoring just to make it feel more like the water they're used to. This system isn't just about convenience, it's a necessity. Transporting water from Earth costs roughly $20,000 per liter when you factor in launch expenses. Every recycled drop means more room for scientific equipment, food, or other critical supplies. And for future missions to Mars or beyond, where resupply isn't an option, perfecting this technology could mean the difference between survival and disaster. But the real marvel isn't just the engineering, it's the mindset. Astronauts don't see this as drinking pee, they see it as part of a larger cycle where waste isn't wasted. It's a philosophy that could revolutionize how we think about resources on Earth too. After all, if we can turn yesterday's coffee into tomorrow's drinking water in space, what could we achieve with that same ingenuity down here? The ISS's water system isn't just keeping astronauts hydrated, it's proving that even the most unthinkable solutions can become routine when necessity demands it. The moon isn't just hanging in the sky, it's inching away from us slowly but surely. Every single year, our celestial companion drifts 3.8 centimeters farther into space, carried off by the same cosmic forces that create ocean tides. It sounds almost imperceptible, but over time, this tiny shift will reshape Earth in ways we can barely imagine. Here's what's happening. The moon's gravity tugs on Earth's oceans, creating the daily rise and fall of tides. But it's not a one-way pull. Earth's rotation drags those tidal bulges slightly ahead of the moon's orbit. This gravitational tug of war transfers energy, pushing the moon into a higher orbit while gradually slowing Earth's spin. Picture two dancers holding hands, spinning. The smaller partner, the moon, gets flung outward while the larger one, Earth, loses momentum. Now fast forward 600 million years. The moon will have retreated so far that it'll no longer perfectly block the sun during eclipses. Those breathtaking total solar eclipses where day turns to night and the sun's corona blazes in the sky. They'll be relics of the past. The moon's disk will seem too small to fully cover the sun, leaving only partial or ring of fire annular eclipses. Even the tides, which have shaped coastlines and marine life for eons, will weaken to a shadow of their former strength. But the changes don't stop there. Earth's rotation is slowing by about 2 milliseconds per century due to this tidal breaking. In another few billion years, a single day could stretch to nearly 50 of our current hours. Imagine sunrise to sunrise lasting longer than an entire work week, a world where time itself feels warped. Don't panic though, this drift won't last forever. Eventually, Earth and the moon will reach a stable equilibrium, tidally locked like two partners frozen mid-waltz, forever facing each other. By then, the moon will linger in the sky of just one hemisphere while the other side of Earth never sees it again. This slow-motion separation is a reminder that even the most familiar cosmic relationships are temporary. The moon we know, the one that lights up our nights, guides migrations, and inspires poets, isn't the same moon dinosaurs saw, and it won't be the one our descendants know. It's a silent, steadfast traveler on a journey we're only beginning to measure. And every year, as it retreats those 3.8 centimeters, it's writing a future where Earth, too, will be utterly transformed. Mars holds the record for the most extreme volcano in the solar system, Olympus Mons, a behemoth so massive it makes Mount Everest look like a molehill. Towering 16 miles high, almost 3 times Everest's elevation, this shield volcano stretches roughly the width of Arizona, covering an area larger than some countries. Picture standing at its base and craning your neck upward. The summit would vanish into the thin Martian sky, its slopes so gently inclined you might not even realize you're climbing a mountain until you're already miles above the surrounding plain. What allowed Olympus Mons to grow so staggeringly large? The answer lies in Mars's geological tranquility. Unlike Earth, where moving tectonic plates constantly shift the ground beneath our feet, Mars is a one-plate planet. This means its crust stays locked in place, giving volcanic hotspots millions, or even billions of years to pile up lava in the same spot without interruption. On Earth, volcanoes like Hawaii's Mauna Loa are eventually carried away from their magma sources as plates drift. But on Mars, Olympus Mons just kept erupting, layer after layer, until it became the towering giant we see today. Here's the twist: despite its monstrous size, Olympus Mons is probably one of the safest places for future Mars colonists to set up camp. Shield volcanoes like this one erupt with slow, flowing lava rather than explosive bursts, and most evidence suggests Olympus Mons has been dormant for tens of millions of years. Its vast, shallow slopes could offer relatively flat terrain for habitats, while its elevation might provide better access to what little atmosphere Mars has, ideal for potential air pressure buffering. Plus, the view from the top would be unlike anything in the solar system. A sweeping panorama of rust-colored plains under a pinkish sky, with Earth a faint blue dot in the distance. But the real wonder isn't just its size, it's what Olympus Mons tells us about Mars's fiery past. Ancient lava tubes, now hollowed out and frozen in time, snake beneath its surface, possibly offering natural shelters from radiation and dust storms for future explorers. Some planetary scientists even speculate that the volcano's last eruptions might have coincided with a time when Mars was still wet. Its lava flows interacting with groundwater to create temporary hot springs environments that could have harbored microbial life. So while Olympus Mons may be silent now, it stands as a monument to Mars's explosive history, a frozen titan that watched over the planet's transformation from a world of rivers and volcanoes to the dusty desert we see today. And for the astronauts who one day hike its slopes, it won't just be a mountain, it'll be a time capsule, holding secrets from an era when Mars was a very different place. You might think the coldest place in the universe is some remote void between galaxies, but the truth is much closer to home. Nestled aboard the International Space Station is a device called the Cold Atom Lab, where scientists regularly create temperatures just a billionth of a degree above absolute zero. That's negative 459 degrees Fahrenheit, colder than deep space, colder than the cosmic background radiation, even colder than the Boomerang Nebula, the previous record holder at a comparatively balmy negative 458. So how does Earth's orbit host the universe's ultimate deep freeze? The Cold Atom Lab doesn't just chill atoms, it slows them down to a near standstill using lasers and magnetic fields. In space, microgravity lets researchers trap atomic clouds longer than on Earth, creating conditions so extreme that atoms start behaving unlike anything in our everyday experience. They form a bizarre fifth state of matter called a Bose-Einstein condensate, where individual particles lose their identities and act as a single quantum wave. It's like turning a crowd of dancers into one perfectly synchronized, ghostly ripple. Now compare that to the Boomerang Nebula, a cosmic refrigerator 3,000 light-years away. This dying star's rapid gas expansion creates natural cooling akin to how spray cans chill when you use them. But even there, molecules still jiggle with residual heat, nothing like the eerie stillness inside the Cold Atom Lab. The implications: this isn't just about breaking records. Near absolute zero, quantum effects dominate, revealing physics that could revolutionize technology. Superconductors that work at room temperature, ultra-precise quantum sensors, even exotic new states of matter, all these possibilities hinge on understanding matter's behavior in extreme cold. And because the ISS provides prolonged microgravity, experiments run cleaner and longer than any Earth lab could manage. What's truly poetic is the contrast. Humanity's coldest creation floats just 250 miles overhead, while the universe's natural cold spots drift light-years away. Both are frontiers, but one reminds us that sometimes the most profound discoveries aren't out among the stars, they're in the quiet, controlled dark of our own making. Mercury plays by its own rules when it comes to time. A single year on this scorched little world, one full trip around the sun, flies by in just 88 Earth days. But here's the twist: a day on Mercury from one sunrise to the next lasts a staggering 176 Earth days. That means a day is twice as long as its year, a cosmic paradox that defies everything we experience on Earth. The reason, a dance of gravity and geometry so precise it's locked into what scientists call a 3-to-2 spin orbit resonance. Picture Mercury's lopsided orbit, not a neat circle, but a stretched-out ellipse that brings it breathtakingly close to the Sun before swinging it far out again. Normally, a planet's rotation and orbit would sync up over time like our Moon, which shows Earth the same face forever. But Mercury's oblong path throws gravity's rhythm off balance. The Sun's pull yanks hardest when the planet is nearest, creating tidal forces that have sculpted its rotation into this strange 3-to-2 beat. For every 2 loops it makes around the Sun, Mercury spins exactly 3 times on its axis. It's like a drummer tapping out an off-kilter rhythm while racing around a track fast enough to stay in sync, but never settling into an even pattern. This gravitational tug-of-war has surreal consequences. Standing on Mercury's surface, you'd witness a sunrise so slow it would take weeks just for the Sun to creep fully above the horizon. And once it does, hold on, because the Sun wouldn't glide smoothly across the sky. At certain points, it would stall, reverse direction, and even dip back below the horizon before rising again. That's Mercury's uneven orbit at work, where the planet's speed changes drastically between its close approaches and far retreats from the Sun. Now layer on the temperature extremes. With days stretching nearly 6 Earth months, surface heat has no mercy. Daylight temperatures soar to 800 degrees Fahrenheit, hot enough to melt lead, while nighttime plunges to 290 below zero. But the real shocker, some crater shadows near the poles never see sunlight at all, preserving ice in permanent deep freeze. What's astonishing is how this chaos creates order. The 3-to-2 resonance isn't random, it's the universe's solution to Mercury's gravitational riddle, a perfect compromise between spin and orbit. Other planets might have simpler rhythms, but Mercury's quirky beat makes it a laboratory for understanding how gravity shapes worlds. And for future explorers, pack patience, because on Mercury, watching a sunset could literally become a full-time job. Deep in the heart of the Milky Way, an interstellar cloud drifts through space, and it smells suspiciously like a distillery. Sagittarius B2, already famous for its vast alcohol reserves, has another bizarre twist. It's laced with ethyl formate, the same molecule that gives raspberries their sweet, fruity scent and rum its rich, warming aroma. If you could take a deep breath in the middle of this cosmic cloud, which, let's be clear, you absolutely cannot, it might smell like a celestial cocktail party, raspberry daiquiris and interstellar rum punch floating in the void. Of course, humans will never get a whiff of this galactic perfume. Sagittarius B2 sits 26,000 light-years away, bathed in radiation and vacuum sealed by the harshness of space. But thanks to spectroscopy, a technique that analyzes the unique light signatures of molecules, we've detected ethyl formate's unmistakable fingerprint. Telescopes don't just see this cloud, they chemically sniff it out, revealing a treasure trove of organic compounds. Alongside the raspberry rum essence, scientists have found acetic acid vinegar's sharp tang, ethanol, the buzz in your beer, and even amino acids, the building blocks of proteins essential for life. This interstellar cocktail bar isn't just a curiosity, it's a blueprint. These molecules are more than space oddities. They're the raw ingredients for everything from stars to living cells. Ethyl formate, for instance, forms when alcohols and acids collide in the frigid depths of molecular clouds, a process that mirrors how flavors develop in aging liquors here on Earth. It's as if the universe has its own fermentation process, quietly brewing the chemistry of life amid the chaos of stellar nurseries. What's truly mind-bending is how ordinary these bizarre discoveries make the cosmos seem. The same molecules that flavor our food and drinks, the ones we associate with kitchens and bars, are floating light-years away in vast, chaotic clouds. It hints at something profound. The building blocks of life aren't rare or special. They're everywhere, woven into the fabric of the galaxy, waiting for the right conditions to spark something new. So while we'll never sip a raspberry-infused space cocktail or catch the scent of cosmic rum on the solar wind, Sagittarius B2 offers something better, a reminder that the universe isn't just stranger than we imagine. It's strangely familiar, mixing the chemistry of life in clouds so vast they could flavor a billion cocktails. And maybe, just maybe, that's the real magic. The universe doesn't just build stars and planets. It cooks, it flavors, and somewhere out there, it might be brewing the next great recipe for life itself. The Voyager spacecraft carry more than just scientific instruments. They hold a time capsule from Earth, a golden record designed to outlast humanity itself. These 12-inch gold-plated copper discs, attached to both Voyager 1 and Voyager 2, contain a carefully curated snapshot of life on our planet, intended for any intelligent life that might stumble upon them tens of thousands of years from now. Imagine a civilization 40,000 light-years away sliding the record from its aluminum cover, decoding its instructions and hearing the sounds of our world for the first time. So what's on this interstellar mixtape? The recordings are a symphony of Earth's diversity. Whale songs echo across the track, their haunting melodies carrying the depth of our oceans. Chuck Berry's Johnny B. Good crackles with the energy of human creativity, while Beethoven's Fifth Symphony hums with the precision of mathematical beauty. There are greetings in 55 languages, from ancient Akkadian to modern Wu, each a linguistic handshake extended across the cosmos. And then there are the everyday sounds: thunder cracking, rain falling, a mother's kiss, even the rhythmic clatter of a horse-drawn cart. It's a sonic postcard capturing not just our achievements but the texture of being alive on this pale blue dot. But how would an alien civilization even play it? The records come with instructions etched in scientific hieroglyphics. A diagram of the hydrogen atom's hyperfine transition to establish universal time measurements, followed by a map showing our solar system's location relative to 14 pulsars. The stylus is included, tucked into the record's casing, and the playback speed is marked at 16 2/3 revolutions per minute. It's a puzzle wrapped in physics, a test of intelligence before the music even begins. Will it ever be found? The odds are astronomically slim, but that's not the point. The golden records were never just about making contact. They're a monument to human curiosity, a message in a bottle tossed into the cosmic ocean. Long after our cities have crumbled and our languages faded, these records will still drift, carrying the essence of who we were to whoever might care to listen. And if no one ever does, then the final audience will have been us all along, reminded by this ambitious project to look beyond our own moment, to think in scales of millennia and galaxies. Perhaps the most poignant inclusion is a single sentence whispered at the record's edge in English. We step out of our solar system into the universe, seeking only peace and friendship. It's a hopeful thought cast into the void, not just for aliens, but for the future humans who might one day recover these spacecraft and hear their ancestors speaking across time. The golden records aren't just artifacts, they're a mirror reflecting back what we value most when we imagine being seen by the universe. The moon might not have wristwatches or scheduling apps yet, but as plans for lunar colonies take shape, scientists are facing a quirky problem. How do you tell time on a world where the sun rises just once a month? Right now, moon missions run on coordinated universal time, Earth's global clock. But with multiple nations aiming for permanent bases, the European Space Agency has proposed something radical: an official lunar time zone. Think of it as setting up cosmic Wi-Fi before the astronauts even arrive, only instead of passwords, we're synchronizing sunrises. Here's why lunar standard time isn't just bureaucratic space trivia. A day on the moon lasts roughly 29.5 Earth days, meaning sunrise to sunrise spans weeks, not hours. Imagine planning a work week where morning stretches for days, followed by an equally long afternoon of perpetual twilight. Without a local clock tied to the moon's actual rhythm, settlers could end up living like eternal shift workers, their schedules untethered from the environment outside their habitats. ESA's solution, a moon-centric timekeeping system that accounts for the fact that clocks on the moon actually tick faster, by about 56 microseconds per day due to weaker gravity. But the real fun begins when you consider the practicalities. Would future colonists split their lunar days into Earth-like hours for familiarity, or invent entirely new units like lunits or crater cycles? And what about daylight saving time on a world with no dawn or dusk for weeks? Picture mission control sending reminders. Don't forget to set your clocks back by 3 Earth days this mare imbrium winter. The push for lunar time isn't just about convenience, it's about survival. Precise timing is crucial for navigation, communication, and even agriculture in future greenhouses. A millisecond error in a Moon-Earth video call could mean the difference between landing a rover safely and smashing it into a crater. And with private companies eyeing lunar mining, standardized time could prevent cosmic property disputes. So while lunar standard time might sound like science fiction today, it's a reminder that the next giant leap isn't just about rockets and habitats, it's about reinventing the mundane, down to the very clocks on our wrists. And for the first astronauts to live by that clock, time itself will finally move to the rhythm of another world. Saturn's North Pole hides one of the solar system's most mesmerizing mysteries, a perfect, swirling hexagon large enough to swallow 4 Earths side by side. This 20,000-mile-wide geometric storm has baffled scientists since its discovery in the 1980s by NASA Voyager missions. Unlike anything else in our cosmic neighborhood, this 6-sided jet stream rages with winds reaching 200 miles per hour, its razor-sharp edges maintaining an almost artificial precision as it churns above Saturn's icy clouds. So how does a planet create something so bizarrely symmetrical? One leading theory points to atmospheric wave interference. Imagine tossing pebbles into a pond, the ripples interact, creating temporary geometric patterns. On Saturn, deep-rooted jet streams might behave similarly, with atmospheric waves colliding at specific angles to lock in the hexagon's shape. Another idea suggests the hexagon is a towering polar vortex, but one warped by Saturn's rapid rotation, 10.5 Earth hours per day, stretching and pinning the storm into this unnatural form. Now compare that to Earth's polar vortices, our own atmospheric whirlwinds, which are chaotic and meandering. While our planet's poles experience shifting, irregular storms, Saturn's hexagon has remained eerily stable for at least 40 years, possibly much longer. It's as if someone drew a colossal stop sign in the sky and forgot to erase it. What's even stranger is the hexagon's depth. While initially thought to be a high-altitude feature, Cassini probe data revealed this storm extends hundreds of miles down into Saturn's atmosphere, a vortex so deep it could dwarf Earth's Grand Canyon. At its center, a roiling cyclone spins like the pupil of a cosmic eye, adding another layer of surrealism to this already otherworldly phenomenon. The hexagon isn't just a scientific oddity, it's a laboratory for physics gone wild. No computer model has perfectly replicated its formation, leaving researchers to wonder if we're missing a fundamental piece of planetary atmospheric science. Every new observation peels back another layer, proving that even in a universe full of wonders, Saturn still holds mysteries that defy explanation. And for those who dream of exploring the outer solar system, the hexagon stands as a reminder. The most familiar-looking planets can harbor the strangest surprises. On Earth, a good cry can be cathartic, tears fall, emotions flow, and eventually you grab a tissue and move on. But in space, even sadness defies gravity. Without the pull of Earth, tears don't roll down your cheeks. Instead, they pool into wobbly, stinging bubbles that cling stubbornly to your eyeballs like liquid jellyfish. Canadian astronaut Chris Hadfield demonstrated this during his time on the International Space Station, squeezing water from a drink bag onto his own eye to simulate tears. The result, a shimmering, quivering blob that refused to drip away, hovering painfully on the surface of his eye until he finally wiped it off. This isn't just a quirky inconvenience, it's a genuine hazard. On Earth, tears wash away irritants like dust or smoke. In microgravity, those irritants linger, trapped beneath a wobbly tear bubble that magnifies the discomfort. Imagine chopping onions in orbit. Your eyes would become tiny, stinging aquariums of misery. Even emotional breakdowns turn into logistical nightmares. A heartfelt sob could leave you with a face full of floating, salty globules, turning your personal moment into a zero-gravity spectacle for the entire crew. Hadfield's experiment wasn't just for laughs. It highlighted how space reshapes even the most basic human experiences. Something as simple as crying, an instinct we've had since birth, becomes alien, almost grotesque when stripped of gravity's guidance. And it's not just tears. Sweat clings in sticky layers, making workouts a slippery ordeal. Drinking coffee requires a straw unless you want a floating brown orb of liquid disaster. Every bodily function, from sneezing to shaving, has to be renegotiated with the laws of physics. So the next time you wipe away a tear, take a second to appreciate gravity's quiet kindness. Down here, it lets us fall apart gracefully. Up there, even heartbreak has a learning curve. The universe doesn't just contain galaxies, it sculpts them into structures so vast they defy human comprehension. Case in point, the Hercules Corona Borealis Great Wall, a galactic megastructure stretching a mind-numbing 10 billion light-years across. To put that in perspective, if our Milky Way were a single grain of sand, this cosmic leviathan would span the length of a football field, every inch of it packed with galaxies clustered like glittering cities in an endless metropolis. Discovered in 2013 by mapping gamma-ray bursts the dying screams of massive stars, this great wall isn't just big. It challenges the very foundation of cosmology. According to the principle of universal isotropy, matter should be evenly distributed on the largest scales. But this monster, it's a glaring exception, a cosmic, this shouldn't exist, that leaves astronomers scratching their heads. Imagine baking a cake where the flour clumps into a single continent-sized lump. That's the universe's recipe here. What makes it even stranger is its age. The Hercules Corona Borealis Great Wall emerged when the universe was barely half its current age, a time when such colossal structures weren't thought possible. Gravity simply hadn't had enough time to pull matter together on this scale. Yet there it is, a fossil from the ancient cosmos, frozen in light that's taken billions of years to reach us. Some theorists suggest it might be a rare statistical fluke, a cosmic coincidence where galaxies aligned by chance. Others whisper about flaws in our understanding of dark matter's grip on the universe. And here's the kicker, we're not even sure if it's the only one. The sheer scale of this wall means we might only be seeing a fraction of its true size, like ants trying to map a mountain range from a single pebble. Future telescopes, like the James Webb's successors, could reveal even larger structures lurking in the darkness, each one a potential rewrite of the cosmic rulebook. So while we gaze up at the night sky, marveling at constellations and shooting stars, remember, the real wonders aren't just the dots of light. It's the invisible architecture connecting them, the hidden highways of galaxies weaving a tapestry so grand, it makes our corner of the universe feel like a single thread in an impossibly vast quilt. And the Hercules Corona Borealis Great Wall, it's not just a structure, it's a challenge, a dare from the cosmos to think bigger. Mars doesn't just have dust storms, it throws planetary tantrums so vast they can swallow the entire world. Picture a hurricane the size of North America, raging not for days but for months, blotting out the sun until the rusty landscape drowns in perpetual twilight. That's exactly what happened in 2018 when a storm erupted in the southern hemisphere and ballooned into a global monster, choking the skies so thoroughly it turned day into night. The Opportunity rover, a stalwart explorer that had survived 14 years of Martian extremes, met its end here, its solar panels starved of light, its batteries drained to silence. One day it was beaming back data, the next nothing but static. A machine built to withstand -100-degree cold and cosmic radiation was finally felled by something as simple as dust. But how does Mars, with an atmosphere 100 times thinner than Earth's, whip up such colossal storms? The secret lies in its deceptively gentle gravity. At just 38% of Earth's pull, Martian winds don't need hurricane-force speeds to launch dust miles into the sky. A breeze that would barely flutter a flag on Earth, say 60 miles per hour, becomes a dust-lifting powerhouse on Mars, sending fine particles soaring like a dry ocean wave. And once those particles are airborne, they absorb sunlight, heating the atmosphere and fueling even fiercer winds. It's a self-perpetuating cycle. Dust begets storms, storms beget more dust, until the entire planet is shrouded in a suffocating haze. Satellites like NASA Mars Reconnaissance Orbiter have captured these storms in stunning detail. High-rise images show continent-sized plumes erupting from the surface, their tendrils stretching thousands of miles across the rust-colored terrain. Thermal sensors reveal how these storms literally rewrite Mars's climate, with temperatures swinging wildly as sunlight is blocked or irradiated. At the storm's peak in 2018, surface temperatures dropped by nearly 30 degrees Fahrenheit, while the upper atmosphere heated by a similar margin, a climatic whiplash no earthly weather system could replicate. Yet the eeriest part isn't the storms themselves, it's what they leave behind. When the dust finally settles, Mars undergoes a metamorphosis. Dunes reshape, solar panels get a fresh coat of grime, and even the color of the sky shifts subtly as suspended particles filter sunlight. For future colonists, these storms won't just be weather events, they'll be existential challenges. Solar power could fail for weeks, outdoor machinery would need hardened seals against abrasive dust, and even breathing filters might clog faster than expected. Mars's dust storms are more than atmospheric quirks, they're reminders of how alien its environment truly is. A place where the sky can turn against you not with rain or snow, but with a creeping, silent tide of rust. And while opportunity may be gone, its final silence speaks volumes. On Mars, even the air can be deadly. The sun might seem like a steady celestial beacon, but beneath its fiery surface lies a cosmic heartbeat, an 11-year cycle where its magnetic field completely flips polarity. Like a colossal bar magnet reversing its north and south poles, the sun's entire magnetic structure resets, turning the solar system's largest power grid upside down. This isn't some subtle shift. It's a full-scale upheaval that sends ripples across space, reshaping everything from auroras to satellite communications. The cycle begins with the sun's magnetic field growing increasingly tangled, like yarn wound too tightly around a sphere. As solar activity ramps up, sunspots, those dark, cooler patches on the sun's surface multiply, clustering near the equator. These spots are actually knots of magnetic energy, and as they proliferate, they twist the sun's global magnetic field into chaos. By the time the cycle peaks, known as solar maximum, the sun's original polarity becomes so strained that it snaps, reversing direction entirely. The north magnetic pole becomes south and vice versa. Then, over the next 11 years, the process repeats in reverse. This flip isn't just a curiosity, it's a celestial domino effect. When the sun's magnetic field reverses, it sends shockwaves of charged particles hurtling through the solar system. Some collide with Earth's magnetic field, triggering dazzling auroras that paint the skies farther south than usual. Think neon green curtains shimmering over places like Florida or Spain. But there's a darker side. These solar tantrums can also fry satellites, disrupt GPS signals, and even knock out power grids. The infamous Carrington event of 1859, a solar storm so powerful it set telegraph wires ablaze, serves as a chilling reminder of what could happen if a similar flare struck today's tech-dependent world. Scientists track this cycle with obsessive precision, using observatories like NAS, a solar dynamics observatory, to map the sun's magnetic gymnastics. But despite our advances, the flip remains unpredictable in its finer details. Sometimes the sun takes longer than 11 years to reset, other times it surges ahead of schedule. And while we've never directly observed a polarity reversal beyond our own star, astronomers suspect other sun-like stars undergo similar cycles, meaning this magnetic dance might be a universal rhythm written into the fabric of stars themselves. The next reversal is due around 2025, and when it comes, it won't just be a footnote in astrophysics journals. It'll be a global event, invisible to the naked eye but felt in the flicker of your phone's signal, the hum of power lines, and maybe even the glow of an aurora where none should be. Because the sun's flip isn't just a distant phenomenon, it's a reminder that even the quietest star in the sky is a living, breathing force, one that reaches out and touches us in ways we're only beginning to understand. Hidden in the depths of intergalactic space lurks one of the most enigmatic objects ever discovered, a galaxy that forgot to make stars. Catalogued as J0613+52, this ghostly structure drifts silently through the void, a primordial relic frozen in time. Unlike the Milky Way, ablaze with newborn stars and supernova explosions, this shadowy giant is eerily empty, a vast halo of gas and dark matter with no detectable stars at all. Scientists call it the ultimate failed galaxy, a cosmic near miss where the spark of creation never caught. What makes J0613+52 so baffling is its pristine condition. Most ancient galaxies show signs of violent collisions or stunted growth, their gas supplies stripped away by cosmic encounters. But this dark ghost appears untouched, a bubble of hydrogen so undisturbed it might look exactly as it did 10 billion years ago. Radio telescopes first spotted its faint signature, revealing a rotating disk of gas wider than our Milky Way, yet completely devoid of the stellar fireworks we associate with galaxies. It's like finding a fully stocked kitchen with every ingredient for a feast and no chef to light the stove. The leading theory, J0613+52, might be the rarest of cosmic accidents, a pocket of the early universe where the density of matter was just slightly too low for gravity to trigger star formation. While neighboring regions collapsed into glittering cities of stars, this lonely patch remained a quiet backwater, its gas never condensing enough to ignite. Dark matter, the invisible scaffolding of the cosmos, still clings to it in vast quantities, but without the gravitational push to compress its gas into stars, the galaxy remains frozen in eternal twilight. Now contrast that with our Milky Way, a stellar factory churning out new suns at a rate of roughly one per year. Our galaxy is a whirlwind of creation and destruction, where collapsing gas clouds birth stars that eventually explode, seeding space with heavy elements for future generations. J0613+52, by comparison, is stuck in idle. Its gas hasn't been enriched by supernova, meaning it's stuck with the same lightweight elements forged in the Big Bang. If galaxies had personalities, the Milky Way would be a hyperactive artist splashing the cosmos with color, while J0613+52 is a recluse hoarding its untouched canvas in the dark. The discovery forces us to rethink how galaxies evolve. For every brilliant spiral like Andromeda or pinwheel-shaped wonder, there could be countless dark ghosts like J0613+52, failed experiments lurking unseen in the cosmic background. Some might eventually awaken, stirred to life by a passing galaxy's gravitational nudge. Others may drift forever in silence, their potential unrealized. What's haunting is the scale. J0613+52 isn't some dwarf galaxy, it's a colossus, a structure that should by all rights be blazing with stars. Its very existence suggests that the universe's recipe for galaxy formation has hidden loopholes, places where the rules don't apply. And that raises an unsettling question. How many other dark giants are out there, invisible to our telescopes, waiting to rewrite the story of cosmic evolution? For now, J0613 plus 52 stands alone, a cosmic what-if, a shadow cast by the universe's unpredictable whims. Imagine throwing a penny off the Empire State Building, now multiply that speed by 1,000, and you've got the average piece of space junk hurtling around Earth. Up in orbit, debris doesn't just drift lazily, it races, clocking in at 17,500 miles per hour, 10 times faster than a speeding bullet. At that velocity, even a paint chip becomes a cosmic cannonball, capable of punching holes in satellites or shredding solar panels. And with over 500,000 tracked fragments circling our planet, from dead satellites to discarded rocket stages, Earth's orbit has turned into the ultimate demolition derby. The real nightmare scenario, Kessler syndrome, a chain reaction where one collision spawns thousands of new debris pieces, each triggering more collisions until low Earth orbit becomes an impassable minefield. Picture this: two satellites slam together, exploding into clouds of shrapnel that rip through neighboring spacecraft, which then explode too, creating a cascading wave of destruction. Suddenly, vital orbits home to GPS satellites, weather monitors, and the International Space Station are swarmed by high-speed shards, rendering spaceflight impossible for generations. It's not science fiction. NASA scientists have warned we're already perilously close to this tipping point. But here's where humanity fights back. The European Space Agency is pioneering a cosmic cleanup mission called Clear Space One, slated to launch in 2026. Its target, a defunct rocket adapter the size of a washing machine, orbiting aimlessly since 2013. The plan, a four-armed robotic claw that will snag the debris and drag it into a controlled burn through Earth's atmosphere. Think of it as a celestial trash collector, but instead of garbage trucks, it's a satellite with a death grip on humanity's orbital mess. Other proposals sound even wilder. Japan's Aerospace Exploration Agency tested a magnetic space whip to lasso debris, while startups dream of nets, harpoons, and even lasers to vaporize smaller fragments. The stakes couldn't be higher. Every minute, another dead satellite or spent rocket stage edges closer to a disastrous collision. And unlike Earth's oceans or landfills, space has no natural cleanup mechanism. What goes up stays up unless we intervene. The irony, much of this junk comes from our very efforts to explore space. A single anti-satellite missile test in 2021, like Russia's reckless Cosmos 1408 strike, created a debris field of 1,500 trackable fragments and countless smaller, invisible threats. Even routine operations leave behind bolts, lens caps, and frozen coolant droplets, each a potential bullet in the orbital shooting gallery. So the next time you check your GPS or binge a satellite-streamed show, remember, the invisible infrastructure making it possible is under siege. And unless we tidy up, humanity's greatest achievement, our reach into space, could be buried under our own high-tech garbage. The claw is just the beginning. The real question is whether we'll act fast enough to dodge a disaster of our own making. We've all heard the term Big Bang and pictured a colossal explosion, a single point of light erupting into the void, hurling matter outward like cosmic shrapnel. But here's the twist: that mental image is completely wrong. The Big Bang wasn't an explosion at all. It was something far stranger, the sudden expansion of space itself, everywhere at once, with no center and no edges. Imagine a loaf of raisin bread rising in the oven. As the dough expands, every raisin moves away from every other raisin, not because they're being propelled outward from a central point, but because the fabric between them is stretching. That's the Big Bang, not a fireball in empty space, but the universe's very fabric unfurling, carrying galaxies along for the ride. So why does this matter? Because the misconception of a center to the universe has stubbornly persisted. If the Big Bang were an explosion, we'd expect to find a smoky, debris-filled void at the edges where the blast happened. But telescopes show the opposite. No matter where we look, the cosmos appears roughly the same, with galaxies scattered evenly in all directions. Even more telling is the cosmic microwave background, the faint afterglow of the Big Bang. This thermal radiation blankets the entire sky like static on an old TV, and it's almost perfectly uniform, just a few tiny variations hinting at the seeds of future galaxies. If there were a central point to the universe, this background radiation would be hotter in one direction and cooler in another, like the fading embers of a fire. But it isn't. It's the same everywhere, a relic of that moment when space itself began to stretch. Now, let's tackle another myth, the idea that the Big Bang happened somewhere in pre-existing space. Nope, space and time began in that instant. There was no before, no outside, no empty void waiting to be filled. The expansion didn't push into anything, it created the arena in which everything now exists. Think of it like asking what's north of the North Pole. The question doesn't make sense because the North Pole defines the edge of our coordinate system. Similarly, the Big Bang isn't a location in space, it's the origin of space-time itself. What's truly mind-bending is how this reshapes our understanding of the universe's scale. When we look at distant galaxies racing away from us, it's easy to assume we're at the center of some grand expansion. But here's the kicker: every observer, no matter where they are in the universe, would see the same thing. From the perspective of a galaxy a billion light-years away, we would appear to be the ones moving outward. There's no privileged vantage point, no cosmic throne at the heart of it all. The universe isn't expanding away from anything, it's just expanding, full stop. And that's the real magic of the Big Bang. It wasn't a chaotic detonation. It was the elegant, relentless unfurling of reality itself, a process still happening today. Every galaxy, every star, every atom is part of that same stretching fabric, carried along by a force that turned a single, unimaginably dense moment into the vast, glittering cosmos we call home. So the next time someone mentions the Big Bang, picture not an explosion, but something far grander, the universe waking up, stretching its limbs, and growing into the wonder we're still learning to explore. Space never runs out of ways to astonish us, but if we had to pick 3 facts that truly warp reality, here they are. First, the diamond planet 55 Cancri, a world so rich in compressed carbon that its interior could be 1/3 pure diamond. Imagine continents of glittering crystal under a sky of molten lava, a place where precious gems are as common as dirt. Second, the eerie silence of space where sound simply can't exist. No screams, no explosions, just an endless, suffocating quiet that reminds us how alien the cosmos truly is. And third, Saturn's vanishing rings, those shimmering halos we've admired for centuries. They weren't here when dinosaurs roamed, and in another 300 million years, they'll be gone completely, leaving Saturn bare like a cosmic magician's final trick. But here's the real question: which fact blew your mind the most? Was it Mercury's backward spin, or the moon quietly drifting away? Maybe the universe's largest cocktail bar floating near the galactic center? Drop your favorite in the comments. We're obsessed with hearing which cosmic quirk left you staring at the ceiling at 3 a.m. And this is just the beginning. The universe is packed with even wilder mysteries waiting to be uncovered: black holes that defy physics, rogue planets hurtling through darkness, maybe even alien megastructures hiding in plain sight. So if you're craving more cosmic weirdness, hit that subscribe button because we're just getting started. To close, let's borrow a moment from Carl Sagan, who once reflected on a photo of Earth taken from 6 billion miles away, a tiny, pale blue dot floating in a sunbeam. "That's home," he said. "That's us. Every fact we've explored today, every mind-bending discovery, is just a reminder of how vast and strange our cosmic neighborhood really is." So the next time you step outside and look up, remember, You're standing on a speck of dust in an ocean of wonders where the ordinary rules don't apply and the impossible is just waiting to be found.